Hi guys. So I am going to attempt to make a video for you today. As you can see, I am in school, but as of Wednesday I will be doing this from home, so I'm gonna just try to see how this works, videoing my lesson for you. So there's gonna be times where I might put up like a Khan Academy video, or if I can find something good to give you that way, I'll do it that way. But I think sometimes it might just be easier for me to just show you what I want you to do myself. So I have put together like a lesson on paper. So let's see if it's gonna work. So this is new to all of us, so we're just gonna try our best, all right? So I'm gonna start here. Okay, so today we're gonna be doing radical form versus rational exponents, okay? I'm gonna try to focus here. All right, so here is radical form, right? All radicals. Rational exponents means exponents that are, they could be whole numbers or fractions. Rational meaning that they are rational, fractions. So square root of x, remember the main thing I told you last week was exponent over index, right? So here, you don't see an exponent or an index. That's because your exponent is actually 1, right? X to the 1, and your index is 2. So that's why when you have a radical, exponent over index is 1 over 2. So that is equivalent to x to the 1 over 2. Yes? Oh, you guys can't respond. This is so weird. All right, so cube root of x is x to the 1/3. Fourth root of x is x to the 1/4, right? Here, if I have a cube root of x squared, again, it's exponent over index. So this is x to the 2 over 3, x to the 2/3. All right, so today we're gonna be going back and forth from radical to rational. This is a little bit out of focus, so I don't know, I'm trying. All right, let's go here. So here's some examples. Write the expression in radical form and simplify. So again, remember, exponent over index. So this is the cube root of 64. My exponent is 1, my index is 3, right? Exponent over index. Here, this one. So this is, exponent is 5, my index is 2. So that's a square root of 4 to the 5th, okay? Sometimes you're gonna see the exponent here. You can also see the exponent like this on the outside. It is the same thing. Exponent over index, same thing. All right? This one is negative 32, right? But the exponent is 3. The index is 5. Okay? Exponent over index. I personally think it's easier to write it like this way than like this, but if you like that better, either way is correct. You might say to me, hey, this is negative, but you can't have a negative under a radical. But that is not true. If your index is odd, then you can have a negative. If it's even, like square root or a fourth root or a sixth root, you cannot have a negative. So just because the negative is under there doesn't mean that something's wrong. This will be odd, and then that's okay. Okay? Now, last one here. This is 625, right? And then I have my exponent is 3. My index is 4. Exponent over index. All right, so that's going from, it just got really blurry. That's going from rational exponents to radicals. Okay? So now we're going to do the opposite. Now we're going to write each expression using rational exponents. So now we're going from radical to the rational exponents, all right? So again, remember, exponent over index. So it's 13, my exponent is 4, my index is 8, and then you always simplify if you can simplify. So 4/8 simplifies to 1/2, right? So it's 13 to the 1/2, okay? which is also equivalent to the square root of 13. But right now we're writing it as rational exponents, so you should have your answer in an exponent form, okay? Here, 13, this is equivalent to 13, exponent is 15 over index is 5, and then you have to simplify that. 15 over 5 is 3, so that is equivalent to 13 cubed. Here's another one. 81 to the exponent over index. Now notice I wrote this one like I said before. They could be written this way, they can be written this way. I just want you to be used to seeing it both ways. So this is exponent over index. It's the same thing as if you would see it that way. Okay, and then here I have 10 to the exponent over index is 9 over 3, which is equivalent to 10 cubed, which in this case you could keep simplifying as 1,000, right? I could even have kept simplifying here to whatever 13 cubed is. I don't even know off the top of my head. All right, and then last one here is 5 to the power of exponent over index is 2/4. So that is equivalent to 5 to the 1/2. Okay, so that's how you go back and forth. So just remember, exponent over index. That's going to stick in your head, and that should be helpful to you. All right, now I'm going to show you one more thing with exponents, and then I'm going to give you an assignment to practice. So I am going to post this chart in Google Classroom, okay? So these are all the rules. So I'm going to just go over it with you. Just to remind you, you probably know this already, but just remember, when you are multiplying with exponents, you add the exponents, right? And then simplify as much as possible. So in this case, I have these two multiplied, so I'm adding the 1/2 and the 3/2, and that's how I get the 2. When you are dividing with exponents, you subtract the exponents, right? So my base is 125, and then I have 2/3 minus 1/3. So that's how I get 25th to the 1/3, which is the same as a cubed root, and that's how I get a 5. When I have an exponent to the power of another exponent, that's when I multiply exponents. That's the only time you're multiplying. So here, I have 8 to the 2/3 power cubed. So that's 2/3 times 3, right? So if I'm multiplying, I multiply my exponents, my 3's would cancel, so I get 8 squared equals 64. This just shows you here that if I have two terms being multiplied inside parentheses with an exponent, the exponent applies to both this and this. So if this is the square root, right, because this is square root, this is like saying square root of 16 times the square root of 25, so that's how you get 4 times 5 is 20. Okay, and then here, if you're dividing, if you have a fraction to an exponent, the exponent applies to both the numerator and denominator. So that's 16 to the 1/4 and 81 to the 1/4. So the 4th root of 16 is 2, the 4th root of 81 is 3. All right, so again, I'm going to post this just so you have it as reference, and I'm going to show you some examples right now of how to do it. So let's see, where's that other paper? All right, so here we go. Simplify each expression. So now I'm multiplying with exponents, right? So that means I'm going to keep my base of 7, and I'm going to add my exponents. So it's 7/9 plus 11/9, and this is nice and easy because it's the same denominator. It will not always be. I'm warning you now. So this is 7 to the, you just add, right? 18 over 9, which is 7 over to the 2nd power, which is 49. We got that? All right, so here's another example. Again, I'm going to add my exponents. So that's 36 to the 3/8 plus 1/8, right? I'm adding the exponents. So that gives me, maybe it's better if I write it underneath. You can see better. 36 to the 4/8, which is 36 to the 1/2, right? And how can I evaluate this? Remember, 1/2 is the same as the square root of 36, which is 6, right? Okay, so that's multiplying. Here we're dividing, so I'm gonna have my base of 5, and I'm subtracting now. So that's 9/4 minus 1/4. So that gives me 5 to the 8/4, which is 5 squared, which is 25. All right, so here's another one. 16, here I have 3/4, okay, minus 5/4. Now what's gonna happen here? That's gonna give me 16. 3 minus 5 is what? Negative 2/4, right? Which is 16 to the negative 1/2. Now, I don't think on that chart had, no, that chart didn't have negative exponents, but we gotta talk about this. So, this is important. What do I do when I have a negative exponent? You can put it as, I'm sure you've learned this before, but in case you forgot, I can write this, whenever your exponent is negative, you can make it positive by putting it in the denominator and writing it as like a reciprocal. So it's 1/16 to the positive 1/2. Does everybody see that? So instead of keeping this negative, I just put it into the denominator and it becomes positive. All right, so then I can keep evaluating. This is equivalent to 1/, this is the square root of 16, right? Which is 1/4. Yes? Yeah. I could hear all you guys just being like, oh yeah, I got it. Okay, one more. Here, this is, remember my exponent is negative here. So I'm gonna write this as 1/8 to the positive 1/3. Right, everybody see that? In order to make this positive, I just put it into the denominator. And so this is the same thing as 1/, the cube root of -8, right? And it's okay that this is negative because this is odd, so don't freak out about the negative radical. And then that is 1/, the cube root of -8 is -2. Right, -2 times -2 times -2 will give you -8. All right, and then this one. Remember what I told you before. The exponent applies to both numerator and denominator. So this is equivalent to -8 to the 1/3 over 27 to the 1/3. All right, and as we just talked about here, cube root of -8 is -2, and the cube root of 27 is 3. Right, so this could be written as the cube root of -8 over the cube root of 27. That's how I got this, so this is my solution, right? This is this, and this is that. All right, and then the last one, this is the 4th root. So this is equivalent to, this is 81 to the 1/4 over 16 to the 1/4. Right, so that means 4th root of 81 over 4th root of 16, and eventually you'll get really used to these. The 4th root of 81 is 3, the 4th root of 16 is 2. All right, so let me see, I can't turn this around right now, but if I'm gonna give you an assignment just based on what I showed you now, so obviously you could rewind the video and stop it and, you know, go back if you need to. If there's anything you think I could do better to help you see this video, or if you felt like the video sucks or something, let me know, or let me know what would be helpful for me to do to help you, you know, learn this stuff better. Also, is there a way to put a filter on the regular recorder on my phone? Because I can't figure that out, and I would like a filter. You know, just saying. Okay, so I'm going to post the assignment in Google Classroom, and yeah, I'll talk to you guys later. I'll let you know when it's due, when I decide. Maybe I'll give you like a day or two. All right, have a great day. I'll be checking in again around 1:30 if you need me, or you could always email me. Bye.